Okay, class, we are going to be graphing exponential functions today. Alright, so the base function for exponential growth and decay is given here. So it can have shifts and stretches. So we have the base function, which is an a and a b, no shifts. If your a number is bigger than 0 and your b value is bigger than 1, it's growth. It's decay if a is bigger than 0, but b is a fraction between 0 and 1. For both growth and decay, note that a is bigger than 0. So really the growth and decay depends on your b value. If b is bigger than 1, it's growth. If b is a fraction between 0 and 1, it's decay. If a is less than 0, then it's neither growth nor decay. It's still an exponential function, but it's not exponential growth or exponential decay. If x is negative, then there's going to be a reflection on the y-axis, and that's the same rules of just general x being negative, then there being reflection on the y-axis. There's going to be a horizontal shift h units and a vertical shift k units. Remember, h is always horizontally in the opposite direction. And then there's a reflection on the x-axis. If your a value is less than 0, it's going to reflect down. So those are the same reflection rules. Key points. The key points we're going to use is minus 1, a over b, where a and b are given in the function, 0, comma a, and 1, comma a times b. The domain of exponential functions is always from minus infinity to infinity, and the range for the base function is from 0 to infinity, with a horizontal asymptote at y equals 0. So the base function has a horizontal asymptote at y equals 0, and it goes up. It doesn't have a vertical asymptote as well. It just has a horizontal asymptote. In the domain, it reaches all real numbers, but the range, it's only the positives. So this is for the base function. Of course, it can flip down and have different reflections. Okay, so here's an example. In this example, my a is 5 and my b is 1/8. So my base function is y equals 5 times 1/8 to the x. Now, order of operations tells us this x is attached to the 1/8, but not the 5. We cannot distribute the 5 in because the 1/8 has an x on it. So the key points that we're going to use, it's minus 1 and then a over b. So it's going to be 5 over 1/8. So a over b is 5 over 1/8, which is 40. So we have minus 1, comma 40. Remember, you multiply by the reciprocal. 0, comma a, so 0, comma 5, and 1, comma a times b. A times b is 5/8, a and b. Okay, so these are going to be the key points that we're going to use. And then, so after we graph our base functions with our key points, then we're going to go ahead and shift it left 1 and down 2. And then we're going to find the domain and the range. So for our key points, we have to graph 5/8 and 40. Now on this graph paper, we can't actually get all of those in. So when you do have some sort of extreme value here, we can cut it down to having 5 and 5/8 so that we can have some bit of accuracy. So I'm going to go in ones, 1, 2, 3, 4, 5. So I have the point 0, comma 5. I have minus 1, comma 40. So I'm just going to aim really, really high for up to 40. It's way up there. Okay, so that just helps me in my steepness, because at minus 1, it's going to be really, really steep. So I'm not going to plot this point, but I'm going to aim really steep. And I have the point 1, comma 5/8, which is about 1/2. So here's 5/8, and here's 1. Okay, and so for the dots, I do want to see the values marked on the axis. Okay, so now I can draw in my base function. That's going to look like this. And it is going to have a horizontal asymptote at y equals 0. Okay, and notice that I just aimed really steep. Okay, so now I'm ready to change my color, and I'm going to graph the final function in red, and I'm doing a color coding. So I'm going to go left 1 and down 2. So I'm going to take my points, left 1, down 2, left 1, down 2. Those values need to be marked on the axes. My asymptote also needs to be shifted. So my asymptote, if I shift it left 1, it does nothing, but down 2, it does need to be shifted down 2. And my other point, minus 140, remember that had me aim for really steep. It's still going to be aiming for really steep up there. So now I'm going to graph my base function. And you just connect your curve, smooth, put arrows on the end. It should approach your asymptote. It should not cross it or aim towards it. That value was not minus 1. What, 5/8 and down 2. So this value that it crosses at is actually minus 11/8. 5/8 minus 2 is negative 11/8. Okay. And that value is minus 1. So I do have my values on the axes. The asymptote is at minus 2, so that value is marked. So I do want to see your key points and the asymptote with the values on the axes. We can state the domain. It's going in both directions, so it's all real numbers. And we are using this interval notation to write it. The range goes from minus 2 to infinity. It does not include minus 2, so it's a round bracket. Because it's an asymptote, it never reaches negative 2. So we do need a round bracket. If it included negative 2, it would be a square bracket, but it's never going to include at the asymptote. The asymptote is the equation x equals negative 2. Sorry, not x equals. It goes to the y-axis at negative 2. It's the equation y equals negative 2. And is this growth, decay, or neither? So for growth, decay, neither, you look at your a and b. So my a is bigger than 0. My b is bigger than 0 and less than 1. So that is decay. Okay, so decay always looks like this. Going from left to right, it's decreasing. Okay, let's go on to example number 2. So example number 2, we have e. So remember, e is just approximately equal to 2.7. So it's going to work the same as if we were graphing 2 times 3 to the x minus 1. But instead of 3, it's 2.7. So my base function, the base function is y equals 2e to the x. So essentially whatever it is without any shifts. The key points we are going to use is minus 1, comma a over b. So my a is 2 and my b is e. So my a over b is 2 over e, which is about equal to 0.7. Remember, e is about 2.7. 0 comma a, so 0 comma 2, and minus 1 comma a times b, which is 2e, or approximately equal to 5.4. So you won't have a graphing calculator, but you will have a baby calculator. So to find these approximate values, you just need to know that e is about 2.7. So you should be sufficient on a baby calculator. So we can go ahead and graph the base function. The base function has an asymptote at y equals 0. I'm going to plot the points minus 1.7, 0 comma 2, and oops, this last key point was a positive 1, comma AB. So at 1 goes up to about 5.4. So it is going to approach the asymptote like so. And I have my 3 key points. Now I can go ahead and graph it with the shifts, and this has a shift. There's only one shift where it is right 1. So I'm going to do my asymptote and shift it right 1, which does nothing. Next value, right 1, right 1, right 1. Went right 2. Go right 1. So our whole graph just gets shifted right 1. And you connect it with a smooth curve. So that is my graph with my 3 key points marked. The domain is all real numbers, so from minus infinity to infinity. The range, it only is y is bigger than 0, which in interval notation is from 0 to infinity. The asymptote is the equation y equals 0. And is this growth, decay, or neither? So my a value is bigger than 0. My b value is bigger than 0. Oops, it's bigger than 1. So it is growth. So when a is bigger than 0 and b is bigger than 1, that is growth. All growth functions go from left to right, go up. Okay, so that is exponential functions. Have a good evening.